Right, so my name is Renee. I work for Round Tower Technologies. I've been working with Round Tower for the past 4 years now. Previously to that, I worked in the Middle East, in Saudi Arabia and Iraq for 15, 16 years. And today I am here to talk to you. This is a fairly generic conversation. I'm going to take you through the past, how we got to where we are here in 2019, and then a peek into the future, the next 5 years, the next 10 years, where I think we're heading, and my recommendations for what you should be thinking about in your strategies. So, the mainframe, 1950s approximately, that was developed, termed the cockroach of the data center, i.e. we'll have a nuclear war of some type and the mainframe will still be running in our data centers. Previously to the mainframe, we were using the Abacus, we had slide rules, we also had analog computers that were highly specific for the workload that they were going to do. For example, think of the B-52 bomber during World War II. They had targeting systems that they used for dropping bombs on the Nazis. Those were analog computers, right? Was it a general purpose platform? No. This is why the mainframe was developed with the first digital technologies. The first mainframes were a bit of a science experiment. We had a room like this, full of valves, and this is how mainframes did their thing. We had punch cards. You would have to understand assembler, binary code, and you would punch what you wanted to get computed, plug that in, and then that would output a paper tape, and then you would have to understand the paper tape to get your results. The digital telephone exchange, this was something that was introduced in the 1970s. So previously to this, it was telegraphs, telexes. We had ladies and switch panels plugging in cables. You would actually pick up the telephone, tell them where you wanted to be connected to, and then they would route that call through the network. And the way those exchanges were built that is how we got our area codes, right? It was based upon the locality so that you could logically switch through the network. In the 1960s, we had the introduction of the the integrated circuit, right? And that was the first technologies that we used in calculators and also with building our first computers. So you may remember Intel, they were a startup back then, competing with HPE, or HP, I should say. And we had the first processor, which was the 8086. Also with the telephone exchange, part of where we got to now was the introduction of optical fiber. So without optical fiber, the internet would not function. So some people think that using satellites would be able to handle the bandwidth of the world at the moment. No, definitely not. It's all optical fiber. So that was something that was introduced by Bell Technologies, or developed by Bell Technologies in the 70s. It was pretty rubbish at the start, right? But obviously it evolved. And now we have SONET-based systems and DWDM systems where we have terabits of data going down a single fiber. In the late 70s, we had the personal computer. So the personal computer meant that all of a sudden, something that was a mysterious, mystique computing platform, i.e. the mainframe, and it had people in white coats walking around and looking very intelligent, wondering what's going on and whatnot. The personal computer meant that in your house you could have your kids, or you could experiment with computing platforms. The first personal computer I saw was probably, so I lived in Australia, you can tell by my accent I'm not a native of the United States. I first played with the Commodore VIC-20. So this was like in 1982, 1983. You had an audio tape. A lot of you millennials here would have no idea what a tape is, to put in a tape deck. So that's what you stored data on, right? You also played music from it. And you would have computer magazines that you would buy from the shop, and in there, so from the news agent, and from there you would have basic code, and you could jump on your VIC-20 Commodore and type in basic, and then you'd have a program that would run. If you turned the computer off, you'd lose the program, but you would save it to tape, and you would have to keep track of the counter on the tape, so you would know where to spool the tape to, so you wouldn't have to wait for an hour trying to search for the code that you were trying to upload.
I got a question. Did you ever do the TV downloads of the programs on Sunday?
No.
I heard they used to play them over there, over the TV on Sunday.
All right.
Over there.
Then we had the laptop. The first laptop that I saw or actually used was, I had just left university and I was working for Alcatel Australia in 1994, and I inherited a laptop. So it was the size of like 4 shoe boxes, and it weighed probably 30 pounds. It had a monochrome display. Didn't have a hard disk or anything. You'd have to plug the 5¼ inch floppies in to boot it up and do something with it. So with the laptop, obviously that evolved very quickly, and they got smaller and smaller, and obviously we've now moved to netbooks and notebooks, and everything's so much smaller and cloud connected and whatnot. And then we had the cell phone. The first cell phone I saw, it was also the shape of a shoebox, probably weighed about 15 pounds. And it was an analog network. So obviously with the evolution of GSM and LTE5 and everything that's going on at the moment, the cell phone was the first time that we had the ability to actually walk around somewhere and have someone contact you directly. Before that, you would have to leave messages. You would have to call whoever you were working with or whoever you were going to go and visit. You would call and leave a message, and then everyone would be calling home to check on their messages to work out where they were at. Right? Like, oh, we're going to meet at the bar at 5 o'clock. Oh, Bob has changed it. We're going to the other side of town, and that's how you got your messages. And some lucky people who were working, they would actually have a pager, right? So with a pager, you would be able to send someone a message, using DTMF, and then they would get that message, or they would call you at the public telephone you're at, and then you could have a conversation. That was how we did it. The internet. So the internet was an ARPA project in the 70s, so it was obviously a defense military project. And what happened was the universities around the world, they all collaborated together, and the first version of the internet was actually an academic research network. So I remember the university that I went to in Australia was Deakin University, and this was in 1990. And I remember just being blown away at being able to telnet to a bulletin board server within MIT and access their system remotely, right? It was like, just blew your mind. What? I'm actually connected to a university on the other side of the planet? Mind-blowing. And I can actually connect and talk to people? Wow, right? That sort of stuff had never been done before. And obviously with the internet being successful, we first started with satellite circuits, right? And then obviously with the evolution of optical fiber networks that were laid across the globe, we now have the internet that we know today. So you can FaceTime your family on the other side of the planet, and it's free. Who would have thought 30 years ago someone had said to you, we're going to have this device, it's called a smartphone. You're going to be able to use it for sat-nav. You're going to be able to call someone using FaceTime. It's going to be free. They're not going to charge you for it. You're going to be able to Google. Imagine someone said the word Google to you 30 years ago. Google? What are you talking about? What's Google? Then in the 90s, we had the evolution of the client-server architecture. So previously we had the mainframe, then we had PCs, and then we had these pizza boxes that we developed, right? And then we were running versions of Linux and versions of Windows Server on these pizza boxes. And this was a distributed architecture, the client-server architecture. And this actually led to the first data centers being built. Before that, we had no such thing as a data center. The first evolution of the data center, if you would want to call it that, would be the mainframe. The mainframe was running in its own little tiny room, right? You had your people walking around in white coats and whatnot. Then we had telephone exchanges, right? So telephone exchanges had all of the switching equipment that you need to make a telephone call and all of the data services and whatnot that go with that. And then we had this client-server architecture, and this company called Intel and AMD, they started competing with the complex instruction set and the reduced instruction set, right? And the great thing about those two processes was the operating system manufacturers would let you run that software on either platform. So all of a sudden we had this choice. And one of the big limitations about Intel back in the day was it was pretty low power. It was like 1 or 2 cores, right, for the processor. The amount of RAM that you could have was not that much. So typically you'd be running like a little web server or a little app server of some type. But if you wanted to run big vertically scaled databases, right, you would have to use the high performance computing platforms. So this is where you've got your HP UX, your Superdomes, your AIX running on System P, and obviously the mainframes are a part of that family as well. And as time evolved, and this is approximately in 2012, is when I first started moving all of my workloads. I was working for a customer. All of my AIX workloads with IBM, that proprietary technology that was so expensive to deploy and maintain and skill, we started switching to virtualization, right? And running on Intel, where we had these Intel processors that actually had the horsepower to run our business critical apps. And towards the end of the 1990s, we had centralized storage. So before then, we had these pizza boxes set up, and obviously pizza boxes can only take a certain amount of storage. And then we had SCSI connected storage shelves that we would connect, but you couldn't share them. You would have to connect them to a single box. So the storage area network was developed, and the thinking there was, look, we'll centralize all of the disks that you need. We'll have a fiber channel network. This will be a first-class storage network, and we will let you carve up those shared resources. That was a good idea. Everyone went, yeah, let's get on with it. The first one I saw was the IBM Shark. So that was back in 2002 when we first deployed that at the university. And it was like magic. It really was. And you could also say that with internet in the 90s, all of the new networking that was coming out, right? So if you remember Token Ring, there was Novell NetWare, you had the TCP/IP stack that wasn't even included in the Windows operating system. So like Windows 3.1, you would actually have to add that on. It was only a Windows 3.11 that you actually had the TCP/IP stack included. And then from there, we had this evolution where this little startup out of Stanford called VMware, they came up with this thing called virtualization. And virtualization in 1998, when they first started, it was just it ran on a desktop, right? And from there you could build something called a VM. And the use case there was, well, if you've got a single PC sitting in your lab and you want to have 2 or 3 operating systems that you want to work with, you're going to need 3 PCs. And they said, well, how about we virtualize it? Everyone went, what? Virtualize it? And as that evolved, when we go into the 2000s, you will all remember VMware reps coming to your place of business and saying, look guys, we've got this virtualization technology. If you use it for test and dev, you're going to save so much money. Now, we agree it's not ready for production. Don't use it for production. But test and dev, it's a great way to build your test and dev network. And we all jumped on board. Yeah, it's a great idea. Let's do it. And obviously the technology evolved, and the management and control plane around around vSphere started to mature. You had VROps, vCloud Director, VRA, you know, all of those enhancements. And then we're now running 100% virtual, right? We don't care about the fact that it's a virtualization platform. It works, you know, it's a trusted technology as it's evolved. In the early 2000s, the Wi-Fi standard was nearly not invented. So at the time, if you think back to the early 2000s, we did not have smart devices. We had big desktops with massive screens, and we had these laptops where you could connect to the network, possibly using a PCM-CIA card or a modem, which you would connect to the back of that machine using a serial connector. And at that time, Wi-Fi as a standard, it was a consortium of companies that were thinking, okay, we think people are going to use Wi-Fi connectivity. We don't know how they're going to use it, but we know it's a good invention and we know it will be used somehow. And as a result, it nearly didn't happen, but it did, right? And obviously now everyone in this room has got a Wi-Fi connected device. In 2006, we had a book company called Amazon. That's what they did, they sold online books. And they came up with an IT-based service where they said, we have object-based storage that you can consume from the internet. Never been done before. Everyone was like, what? What's going on here? A book company is doing object-based storage. What is object-based storage anyway? I don't know. And then we look at where we are now. They had a vision, and the reason why they started delivering public cloud services was Amazon was growing so quickly, they were the first hyperscaler. So they had to build their own APIs, their own hardware, their own technologies, right, so that they could scale and keep in business and keep on doing what they were doing. And they had a lot of slack resources. And that is the reason why they started offering AWS as a service, right? The different services that were there. So obviously now hyperscalers, we've now got 3 major hyperscalers that offer public cloud services. The smartphone and the tablet. So think back in 2006, 2007, the phone that you were carrying in your pocket. It would have either been a Motorola phone or it would have been a Nokia phone. And Windows Mobile, they had something there as well, but I think that was more like towards 2009, 2010. Apple, the company that makes laptops and computers, they said, hold my beer. We're going to reinvent how people should consume technology in their personal lives. So that started with the smartphone, with the Gorilla Glass on front, completely touch-based screen. And I remember Steve Jobs in an interview saying when he developed the smartphone and a few years later the iPad, his measure of success was if he could go to a child sitting in the street and give them this device and see if they could intuitively use it. That was his measure of success, right? And obviously here we are now. Everyone has an iPad. There's even one up the back there for registering. Up until now, the biggest problem that we had within our data centers, so this is around 2009, was the speed of our storage. If you were running any type of virtualization infrastructure, your complaint, your bottleneck was always storage. We don't have enough storage from a capacity perspective, and we also don't have enough performance. And you will all remember buying arrays. So you would talk to Dell EMC, you would talk to Hitachi, you would talk to IBM, and they would build this array for you, this beautiful big array, and you would have to try and plan 5 years ahead. Well, where are we going to be in 5 years? I don't know. Just let's throw some mud at the wall and hope it sticks and come up with a guesstimate. And what would always happen with a legacy storage array was you would have the honeymoon period for the first 3 or 4 months, and then you would hit 50% utilization of the capacity, and all of a sudden the complaints would start coming in. Performance is the problem. The database is running slow. The web server is running slow. What's going on? You guys, what are you doing? You don't know what you're doing. You're a bunch of dummies. What's happening? And then you would call the vendor in. And then the vendor would come in and say, well, we've done an assessment. Got some good news for you and got some bad news. The good news is we can fix it. The bad news is going to cost you $1 million. You're like, come on. This is supposed to be a 5-year investment. What's going on? So then we had the introduction of Flash. So all of a sudden the performance problems that we had with traditional storage, we were now able to accelerate. And the first time that you would have seen Flash within your storage arrays would have been as a caching tier, as an auto tiering function. So basically all of the hotspots within your array would be running from Flash, and everything that was cold would be running on spinning disks. That is how we first consumed it. And then we had companies, and there was a plethora of them. I remember being at VMworld in 2014, and there was it seemed like 1,000 Flash companies, right? All specializing in Flash storage systems. If you look around today, right, a lot of them don't exist, yeah? And this is the typical boom process with new technologies. You have the gold rush, and then we have this natural selection, and then only the best remains. So Pure Storage at the moment for Legacy 3-tier, there's Extreme IO, you've got Nimble with HPE, right? They're kind of, if you want to stick with Legacy 3-tier infrastructure, then they are the all-flash solutions that you're going to be using. And what made it so cost effective at the start was data reduction technology. So around the 2000, 2011, 2012 mark, that's when you started seeing any vendor that was specializing in all flash solutions. It was all about data reduction, right? We had to make the most of that expensive real estate. And now in 2019, we obviously have cloud services. So any enterprise at the moment, you would certainly have had a conversation with your CIO, CTO about, okay, what type of services are we going to offer? It's not enough to talk about, okay, I've got this compute, I've got this network, I've got this storage. How am I going to make it accessible to my customers? Are you going to have a self-service catalog? You're going to do IaaS, PaaS? What type of topology are you going to run? You're going to be all on-prem? You're going to run hybrid? Which public cloud provider are you going to use? How are you going to consume those services? And then we have the companies that were born in the cloud. Pure software companies like Netflix. So what's interesting about Netflix, and you would have all heard of this, right, was Blockbuster was given the option to buy Netflix back in the day. They said, no, we don't need you. Well, obviously, they went bankrupt. And Netflix, they said, look, we are not going to own any type of on-prem infrastructure. We have no interest in that. We want to consume public cloud services that we can be agile and make things happen. Right now, for a company that's delivering a single service to everyone, right, it's a highly specialized service, this type of things make sense. But for an enterprise, obviously, right, it's not always the best fit, right, which I'll talk about in a minute. Now, we live in a software-defined world. So really, it's not about hardware anymore, right? So 10, 15 years ago, if you were doing anything from a technology perspective, it was going to be an appliance, something that you would have to rack, something you would have to buy, right? And then you would have to consume, and it would normally be proprietary. It would be expensive and would require a high level of skill. We've now moved completely to the software consumption model. And Tesla is a great example of that, right? So Tesla at the moment, they've spent what, 10 years, 12 years developing their electric vehicles. They tried to partner with the petrochemical companies, right, to try and have every gas station like a BP or Shell, right, to have power charging stations. Obviously that is a direct threat to the fossil fuel companies. So they went, okay, fine, forget about it. We'll just stand up our own. We will partner with companies that want to have Tesla drivers in their businesses, you know, i.e. Starbucks, that kind of thing. And we'll partner with them, and we'll stick superchargers, and we'll have a network of superchargers around the world. Right? Obviously, that's something that's very developmental at the moment. But what it comes down to is when you're buying a Tesla, you've got basically three models. All of the whiz-bang features are all software options, and that's how you get priced, right? That's how you get charged for the service that you can consume. So in 1989, I was a 17-year-old boy, just finishing high school, about to go to university. At that time, if I wanted to go somewhere driving, and if it was out of the city where I lived, I would have to pick up the Waze. So I lived in a place called Melbourne, so it was the Melways, right? And I would have to plan the night before the route of where I wanted to go. And at the other end of the trip, wherever I was going, obviously I didn't have a map, so I would have to phone a friend. And they would give me some instructions. Well, when you get to exit 21, you're going to go 2 miles down the road and you're going to take a left. If you see the red barn, you've gone too far. You need to turn back, right? And you would have friends who gave really crap directions, and you'd have friends who gave really good directions, right? That's kind of how you measured your friendships back then. If you wanted to take a photo of someone, you would have to take an analog camera and you would have to take the photos, click, 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 click. And then once that was done, are you getting your photos immediately? No. You would have to take the roll of film once it was done, take it into the Photoshop and get it developed. That was the analog world back then. If I wanted to know something, I would have to pull out an encyclopedia set, right? And that was the big thing back then. If you wanted to have knowledge in the household, you would have to, you had encyclopedia salespeople knocking on doors all the time selling encyclopedia sets. So that was the thing. I remember my parents talking, we need to get the kids an encyclopedia set. It's going to help them for school. Obviously now, in 2019, right, all of this stuff that I'm talking about is all coming from this one smart device, right? Everything is in here. And if you had said to me back in 1989, you're going to have this thing called a smartphone. It's going to be connected to something called the internet or the interwebs. And you're going to be able to access information immediately. It's like, what? Immediately? What do you mean by immediately? Do you mean I'll be able to phone a university professor? No, I don't mean that. You'll be able to Google something and the data will come back. And then if you are traveling on the other side of the planet, you wanted to talk to your family, you can do it using something called FaceTime. It's all going to be free. And when you jump in a car, you can put in the map, the location where you want to go, and it's going to navigate. It's going to be automatic. Who would have thought? So, this is the enterprise cloud bell curve. So now I'm going to talk about futures. So at the moment, we spend most of our time in the manually operated data center, typically legacy technologies, legacy 3-tier infrastructure. We might have some type of private cloud that we've deployed that will, offer basic infrastructure as a service. You might have a self-service catalog of some type. But typically, when your customers request infrastructure, they're opening a ticket of some type, and they're also sending an email and chasing you down. And this is something that can take up to 6 weeks to months, depending upon the industry that you work in. In the next 5 years, so if you look at the industry at the moment, all of the vendors are all investing heavily in hybrid cloud technologies. So what does that mean? It means you're going to have an on-prem data center of some type, and you're going to have some type of interconnectivity to the public cloud, and you're going to be consuming public cloud services of some type. Now, obviously, this is all my opinion, right? This is the round tower view, Renee's view of the world. In 20 years' time, it's probably going to be a utility. So running stuff on premises is probably not going to be a normal use case. That will be a corner case. Why do I say that? So I want you to think about where you live at the moment. So I'm assuming most of you are Jacksonville based. So where you live, are any of you running your own generator in the backyard? Have you dug your own well? Have you dug your own latrine for the sewage? Probably not. You just consume a utility from the grid. Same goes with telephone services. Have you built your own exchange? No. You just buy a device, get a service, and off you go. This is where I think IT is going, and this is why when you look at public cloud providers at the moment, for example, Azure has got Azure Stack, right, so that you can run this hybrid cloud technology. You look at AWS, they have got, I've forgotten the name, but anyway, they have their own on-prem version as well, right? And they've understood that for enterprises to actually consume public cloud, you really need to have a hybrid cloud technology where you can run their workloads on-prem and then connect to the public cloud if necessary, right? This is what they've worked out. And this is why you see these partnerships between the hyperscalers with Nutanix, et cetera, et cetera. And then one of the big questions is, what is the decision point for where you go? What drives this? And there's basically three laws. So there's the laws of the land, which is governance and compliance and data sovereignty and all that kind of stuff. Then you have the laws of economics, so CapEx, OpEx, how do you consume services, how do you pay for them? And then we have the laws of physics, so data gravity, latency between applications and that type of thing, right? So those are the three things that any use case that you have, any reason that you have for where you move and how you do things will fit under these three umbrellas, right? These 3 points. So the legacy 3-tier stack. In 2013, I was talking to the chief architect of VCE. And in that conversation, I was asking him, I said, who gets it? When you talk about VCE and the engineered solution, who gets it? Who understands it? He goes, yeah, this is a great way to go. He said, CIO, CTO, C-level suite people, they get the engineered solution. They understand it. It makes sense to them because it's all about business value. And he said, you know who is the biggest problem? He said, people like me, technologists who love to learn technology and play with technology for technology's sake. And it's almost territorial. I remember when my CIO said to me, look, we're looking at the V block. I think we should go down that route, right? For me, that first visceral reaction, if I'm honest, was, what? You want to bring someone in who can deploy it, and I'm not going to be able to learn about that technology stack. I'm not going to be able to play with it and master it, and then once I've mastered it, then I can hand it over to operations, right? That was always what was against getting out of the legacy 3-tier stack. You know, building stuff by yourself, playing with it, experimenting it. And this is where talking about speeds and feeds, bits and bytes, the 75% of your time is spent keeping the lights on, right? If this is what you're doing at the moment, then you're doing it wrong, right? You're back where I was in 2013. And the problem with all of this is, well, why is that a problem? Well, we're all in a competitive environment. So we all work for companies who sell services and whatnot, and they're trying to compete with, obviously, the competition. And you want to have the lowest cost per transaction. You want to have the highest TCO. Sorry, the lowest TCO, the highest ROI, et cetera, et cetera. And it's basically survival of the fittest. So now we think about the utility model. So if I'm thinking like this,